Hello, my name is Dohyun Kim, the author of the paper Hadamard-Aware Bitwise PIM Architecture by a Butterfly Adder Tree Reuse. Let's start the presentation. Large model inference is dominated by multiplication and MATMR. Ternary LLMs like BitNet fix this at the root when every weight is -1, 0, or +1. A matrix multiply collapse into pure add and subtract. BitNet version 2 pushed this further. But there is another catch. Before quantizing activations, BitNet version 2 runs them so a Hadamard transform to smooth outliers. So the hardware now has two jobs, a Hadamard transform and a ternally fully connected layer. The naive answer is two separated data paths, which is wasteful. That is where our work starts motivation. Here is the first observation. A Hadamard butterfly is just add and subtract. A ternary accumulation is also just add and subtract, the same primitive. So instead of two engine, we build one fused butterfly processing element that shared n over 2 adder subtractor unit and time multiplexes them between a Hadamard transform mode and the fully connected mode, rerouting the same physical adder each cycle. But there's another observation. Take just the first butterfly stage, it already produced xp plus xq and xp minus xq. Together with the original input, those values from a tiny lookup table, and every possible ternary pair sum is already one of them and sign invert. So in the bit linear layer, the weights never drive another. They simply multiplex select the right pre-computed term. We run stage 1 once, and the remaining butterfly stage finish the reduction as the adder tree. There is the real reuse. Hadamard first stage is the bit linear lookup table, and adder utilization drops. And because ternary weights act like simply multiplexers selectors, the element stays small enough to sit right next to the memory. It means a near memory accelerator at the DRAM bank level. We target an FPGA with n equal to 1024 and a Q3.12 fixed point data path. The result, the full Hadamard bit linear pipeline runs end-to-end in 6670 cycles at 100 MHz, or 1024 output bit match or Python reference. The Hadamard transform reaches 72.7 decibel on SNR, and the fused design delivers route 159 times on naive serial baseline. One shared adder array to transform near memory. Thank you for listening to my presentation. Thank you.